Okay, we may as well get started. So, the last two workshops that we went through, we sort of looked at how to map the cells in CellMap, and we also looked at how to map cells and projections and raw data in BrainJ. And getting that data is like a big part of doing these experiments. But once you have the data, knowing what to do with it is actually kind of a problem. And for some of you, if you've got experience with coding or using Python or MATLAB, you may use those CSV files or the spreadsheets to create your own way of visualizing the cells. And if you don't have that experience, then probably the first thing you'll be tempted to do is, plot this data in Imaris. Or you may want to plot it in Imaris anyway, because the visualizations look really nice. And a lot of papers do use Imaris for this. But I can tell you from experience, if you start to try and plot multiple populations and you start to look at different brain regions, the Imaris files can get quite complex, and they can be quite slow to create, and it can get to a point where like Imaris becomes quite unstable as well. It's really not meant for handling like many different cell populations and surfaces, and it can get a little bit tricky. And plus it takes a huge amount of time to get it to work really well. And so, as a way to save time creating these renderings, a really powerful tool for this is BrainRender. And this workshop shouldn't actually take that long. That's sort of a testament to how easy this tool can be to use. Especially for generating images for presentations and movies for presentations, but also for for publications and things like that. And so, just to get started, what I'll do is I'll share the desktop of the workstation at Cellular Imaging, and this will be a PC, but BrainRender can work in PC and Mac and Linux. And okay, so I'm going to share my screen. Yeah, so just to make sure we're all on the same page, when you're aligning to these common coordinate frameworks like the Allen Brain Atlas, there's a couple of different data sets. There's the template brain, which is the thing that you're aligning to. This is usually a data set that makes it easy to register to. So in this case, it's the autofluorescence that we're registering to. And there'll be an annotation file, and this annotation file can sometimes be a little bit difficult to look at. It's all the different intensities. Well, basically the intensities have been used to label the voxels. And so in this image, if I hover the cursor over these regions, they'll have a different intensity value. And that's actually like an identifier for that brain region. And in the table, if we look at this, you'll be able to see here, which intensity is which brain region. If you do decide to use something like Imaris for creating your renderings, just a sort of shortcut for you, the Allen Brain Atlas also sort of provides these region mask files, which are available. I've got them in, if you're using BrainJ, they'll be in a folder called region masks. And these are the brain regions as individual files. And these are very small files that are quick to open, that are a binary mask for the brain region. So if you just needed a brain region for like the, let's say like the putamen or the striatum here, like you could just find like 672 in here and open it up, and that would be kind of like an image that represents that brain region. And if you're working with these, like don't be worried if you can't see anything here. The intensity is just the value is 1. So if you use these in Imaris or any other sort of program, you just need to make sure that you update this intensity so that you can actually see the brain region. And then you'll be able to import this into Imaris and use it to create a surface. It's a bit of a sort of a hacky way to do it, but that's one way that you can start to create specific surfaces in Imaris. But I wouldn't recommend doing that. And like the alternative is actually to use BrainRender. So to start with, we need to, I hope all of you've got Anaconda already installed. That'll make it a little bit quicker. We need to create an environment for BrainRender, and then we also need to download BrainRender. So actually maybe just quickly, we can just go to the website. So this is the GitHub page for BrainRender, and we can just download the code here. And actually, you should follow along doing this too. So we're going to be going through like the data sets that I shared with you, and I have a few extra data sets here on my side, but yeah, definitely follow along with all these steps so you can really get the hang of this. And then you just want to open this. This will download a zip file. You can just extract this, somewhere that's easy for you to find. I think on this computer I have it. I just keep it here in documents. You might have a GitHub folder if you're organizing a few of these pipelines. And in here is the code. And actually, one good thing too is they've been quite good with documentation, and they give a lot of examples. So we'll actually start with some of these examples today. And just so you have a good idea of like how this works, the way that they sort of structure this is you have a scene, which is the sort of brain volume, and then you have actors, and the actors can be kind of your points. They can be like fluorescent data. They can be cylinders or rulers, or, anything that you want to add to this scene to sort of show what you're trying to show about your data. And after today, if there's still something you need a little bit more help in, there's some basic documentation for a lot of the tools in here. But we'll be going through some of the sort of more advanced features to actually get it to work with ClearMap and BrainJ. Okay, so we've downloaded BrainRender. The next thing we need to do is set up the environment. So if you're working on a PC, then you can use, after you install Anaconda, you should have an Anaconda prompt. So you can just search for Anaconda prompt here in the Windows button. And whenever you're sort of working with these tools, it's a good idea to create an environment for them. So the environment is just kind of a separate instance where you can install a specific version of Python. And that way, you're not installing it amongst other things you've downloaded that could break it or make it not work or make something else not work. And so making a separate environment is a really good way to make sure that things will actually work. They don't give you an environment file like in the case with ClearMap, but it's actually a little bit simpler to install. So the way you can do this is you can type in conda create to create a new environment, and we can give it a name by just saying -n, and then we should name it something. So I'm just going to call this BrainRender tutorial. And if you do this, it's just going to create an environment with the sort of default version of Python. BrainRender only works with some specific versions of Python. So what we can do is actually tell it that we want to use a specific version. So in our case, we want to use 3.7. And if I enter, this should now create this sort of fresh environment with Python 3.7. And you can just say yes here. This is just going to install like some basic packages. This will be pretty quick. Okay, so mine's done now. So what we can do is then connect to that. So we'll activate it. So we can say conda activate, and then this is case sensitive. So you should type this in exactly as you had it. If you're not sure what you called it, maybe you're using it a few months later and you've just forgotten, you can just say conda env list, and this will list the different environments on the computer. So if you're not sure, just try that to see what it's called, and then you can say conda activate and then type in. And that should activate the environment. And then to get BrainRender installed, we just type in pip install BrainRender. And this will install BrainRender and all the dependencies. And this shouldn't take too long either. Yeah, so actually, while we're waiting for this, if you're working on PC, which it seems like you all are, I also install Spider just as a way to edit the scripts and run the scripts in an easy way. If you're running it on a Mac, Spider can actually break the BrainRender. So one good alternative that I often use is, there's many ways to work in Python, but one program that's quite nice to work with is Sublime. This is just an editor, so you can edit the scripts in here and then run them from your BrainRender environment, and that's a nice way of being able to sort of script easily and then run without having any issues with Spider. But if with PC, there doesn't seem to be an issue with installing Spider. Okay, so now what we can do is run Spider. So you can just type in Spider here. And once it's opened up, this is where we can work on the scripts in this left-hand panel. This is where we can run the scripts in this sort of IPython console. And we don't use it so much for the BrainRender, but this is where you can sort of look at the variables that you're creating and some of the data. But for BrainRender, we really just edit the scripts and then run them using the IPython console. And so for the first one, what we can do is we can just open up an example script. Let's just make sure this works for everyone. So if we go into the BrainRender folder, so this will just be wherever you unzip the BrainRender code. And there should be a folder here with some example scripts. And the one that I'd like you to open is this add cells. And so this script is just, a very basic script just so you can actually get an idea of how things work. We're basically importing BrainRender, and we're importing the scene and points tool. Actually, maybe this has been a little bit edited on my side. So actually, that can be a little bit confusing for you guys. Let me just get rid of that and that's better. So you should have like the random imported here. This is so we can randomly generate some points, the scene and points tools. And so basically this is this sort of function here. So if you're not used to using Python, we'll just, if you have any questions, just ask. I'll try and go through this like as clearly as possible, but essentially this def here is just defining a function that will create random points in a region. And so if you look just a little bit further down, it's saying make the coordinates using this function up here called get and random points in this brain region. And they've defined that brain region just here. So the nice thing about BrainRender is it uses the sort of abbreviated region title. So, if you're not sure like what brain region we're talking about, or you've got a brain region, everyone will have their sort of brain regions that they're working with a lot. You can always look those up in the Atlas CSV file. So the abbreviation names are this one here under acronym. So you can just search, you can open up this in Excel if you need to look for the different regions. And the other thing that's important is the output ID. This is like the intensity. You can also use those to search for regions. So essentially all this code does is, loads in this brain region and then plots some points in that region. And then it adds those into the scene and then it renders the scene. And if you want to run this, you can just click play. Maybe you've already done this. If you click play, it should actually sort of fill up the whole screen. It may take a little bit of time for you on the first pass, because what it will need to do is download the Allen Brain Atlas. But then what you'll eventually get is a rendering of this. So maybe you guys will have to sort of shout out to me in the chat, or just let me know when it's finished downloading, because that could take a little bit of time. Yeah, while we're sort of waiting here, so you can actually kind of see how you to sort of interact with BrainRender. These, you don't even, in this case, like we could even take this out. If you were just trying to plot a brain region, then all you would have to do is say like scene add, and there's a few different add functions, but this one says add brain region. And then all you would have to know is the acronym or abbreviation for that brain region. And this alpha setting here is kind of just a transparency setting. So if I put this to alpha 1, then it'll be opaque. So you'd have like a very solid brain region, but alpha 0.15 is like very transparent. And that's why like in this rendering and hopefully in the renderings you'll get in a second, they're transparent enough to see the cells. And the color for the regions is sort of reflects the colors that the Allen Institute uses, just quickly. But once you get these images, you can just press escape to get rid of them. Sometimes Spider can be a little bit funny, and you might need to cross it out here and just close the program. So if that happens to you, don't worry, just cross it out and close the program, and I'll show you a better way of dealing with this stuff in a second. Yeah, just so you know, like the annotation color, this is the file here for coloring. You can kind of just see that these are just RGB colors that the different brain regions get assigned in the Allen Brain Atlas. Cool. So the first thing, like we've got this working. Hopefully everyone has got it working. So just having it render in the full screen, I find is a little bit annoying. So straight away, like if you're just trying to like troubleshoot this or like get it to render what you're interested in, you want to change that. And so the best way to actually start changing this is to have a look in the settings file. So we can just open up that file. So in the BrainRender folder, there's another file folder called BrainRender, and in here there'll be a settings file. And these are kind of the default settings that the software uses. The top ones are for this Vido, which is the way that it does the rendering. We don't have to worry so much about those at the moment. But these ones down the bottom are the settings for BrainRender, and all of these are quite useful to start modifying. And you might be tempted just to edit them here, but the best way is really to actually add them into your script. And the way to do that is come back here. Like just as a main example, this whole screen thing, which is kind of a bit annoying, just select that. You can just copy this, and we can just bring it back into our cells function here. We can just put this up the top somewhere. Like these could just be like, these could be our settings for rendering. And we can start to modify them before the script runs. So if we just say whole screen equals false, the script doesn't know what to do with this. We need to actually give it some more information on where this setting is. And so that actually the way to find that, you can just look at the directory we're in. So when actually maybe the best way is I just open up the folder. So we're in BrainRender. Oops. And it's inside the settings file. So you can just say here, BrainRender settings, and then that will update the whole screen sort of parameter to false. And Spider will give you a warning here saying, okay, look, I don't know what this BrainRender is, we just need to import that so that it knows what BrainRender is. So we can just say import BrainRender, and it should be happy now. And now we should be able to run this script. Oh, I've changed this so this isn't happy. Hang on, let me just fix this back up. So if you run this now, hopefully what you'll get is a smaller version of the labeled cells. So yeah, now I find this is a lot easier to work with. And then when you don't want this anymore, you just want to render it again. In Mac, if you're running this, you can press escape, but I find it's much easier just to close it out in Spider. So if you just click the cross, it'll close without crashing. So that's the best way to actually just run the script again. In terms of navigating around, this is actually very similar to any kind of 3D program like Imaris or any of the other programs you may have used. So mouse wheel, you can zoom in and out. Left click to drag. It can be a little bit sensitive in terms of getting rotation. I sometimes find it's easier just to sort of drag it somewhere near the middle to sort of keep the orientation the way that I want it. And then right mouse button and moving is sort of zooming in out as well. And I think shift lets you pan. So if you hold down shift, then you'll be able to pan around. So you can sort of zoom into particular brain regions. Here, obviously, this is where we can change the title. So if you're trying to make a figure, you could put something in here, or you could just clear this out if you just want to generate these, as untitled images. Okay, so the first thing, now we've got this working, is we want to actually start to use it with the ClearMap cells. And so hopefully you guys have got those downloaded. They're just some small CSV files that we created from the CellMap pipeline. So there should be a folder here with, this is the haloperidol, and this is the saline. So to start with, I would just use the saline data set. And if we just look at these, so if you're just using the ordinary version of ClearMap or CellMap, you're going to have just the positions and this O number. So the O number is the graph order, and it's not very useful for any kind of plotting or rendering in BrainRender, because the graph order is kind of just like the hierarchy of the brain regions. But if you're using the modified scripts that I shared, you should also have like the abbreviation or the acronym, and you'll also have the ID number, and they're useful in actually interacting with BrainRender or being able to tell what brain region you're in. So you can see here that this is like the abbreviation, and this is the intensity or ID. And to get this to work, we need to just create a new definition or a new function to import these. We can get rid of this. We don't need to create the random points anymore. The first part of this pipeline, I'm just going to go like line by line. We need to read in the CSV files. So this is the start of a function to do that. And maybe I'll paste it in the chat as well, so it's easy for you guys to copy and paste. But really what we're doing is saying that we have some cells. We want to create a sort of list of these, or this is going to be a table of cells. And we're doing that by using pandas, which is a tool for reading and saving data files. And we're using a function in that called read CSV. So this will read in the CSV file that we've got in our ClearMap folder here. And a nice way of using this is to actually specify which columns you want. So we can actually say like, okay, columns 4, 5, 6, and 7, 9, and 10, that's going to be the X, Y, and Z coordinate and the acronym and ID. This can be a little bit confusing looking just at this table. Like if you're ever working with CSV files and you're opening them up and they're not, something doesn't look quite right, just look at them as text files. You can see here there's actually, the reason why this is a little bit funny is there's actually several columns with the same name. So there's like XYZ, XYZ again. So these are the columns that you should actually use when you're sort of looking for the columns in Python. Like looking at them in ImageJ can be a little bit confusing because those X, Y, and Z kind of replace each other. So that's, if you're looking at this, that's why it doesn't look like it's right. But these are the correct columns, 5, 6, 7, 9, and 10. And we should just give them some names so that we know what they are. And then we can also just skip the header row because that's just going to be the titles. We don't need that. And the other thing we need to do is just tell it where that CSV file is. So, you can just say, you can give it like the location of the file. And an easy way to do this in Windows is to find the file and hold down Shift and then press the right mouse button. So if you're holding down Shift, you'll get an option here called Copy as Path. And this will make it easy for you to just paste in here the location of that file. So if I paste now, I get this clear path to the file. Just make sure you have one set of quotation marks around it. You see I had to edit that a little bit. The other thing too is when you're working with Python, these like single backslashes create a problem. So you have kind of two options here. You can turn these into forward slashes for all of them, or you can just do like a double backslash, and that way Python will be able to find this file. Okay, and then the next part in our function that we're working on here, we need to filter the cells. You can actually see BrainJ doesn't really have this issue. We don't, as soon as any cell that's outside of the brain, like, it's just immediately filtered out. But you'll find that these data sets, I'm just going to open this up again, you'll probably have like a bunch of cells that have plotted out into the universe. So this could be debris or some false positives that were outside the brain or outside the tissue, or maybe on the edge of the brain that got mapped outside of the brain. So anything like that, we don't really want to plot those. So we can just say, like, if in this cells table, in the ID column, if it doesn't equal 0, then we're going to keep it. That's basically what it's saying here. So we're taking the cells that we sort of imported here, and we're just saying every single row in that table, as long as it doesn't equal 0, let's keep it. Next step, we want to just create some lists. So now we're just creating a list. And then finally, so this is just creating basically an array of X, Y, and Z locations. And the ClearMap datasets are analyzed in a different orientation to the way that the BrainRender people orient the brain. So this is actually where I changed this. You could do this somewhere else in the script as well, but I'm basically just saying that Y equals the X cells, and X equals the Y cells, and Z equals the Z cells. It's the Y and the X axis that are, so just pay attention to that. So this isn't an error. This is really just correcting for the misorientation. And in fact, like, we could leave this, I can just change this to the wrong. This is just purely thinking that X equals X and Y equals Y, and then we'll plot this and we'll see how it looks. And the next line here is just saying what the resolution of the atlas is. So we do all the analysis in ClearMap at 25 micron isotropic. In the spinal cord stuff we actually use like a non-isotropic. So we do 10 microns and 25 microns. So depending on what work you're doing, you just need to set here like what the resolution is, because BrainRender is working with microns. It's not working with pixels. So these values are going to be sort of pixel or voxel coordinates, and BrainRender is expecting like an actual position in microns. So we just need to multiply everything in these arrays by the resolution. So in these lines here, we're just saying, okay, for every element in that array of X, multiply it by 25, and then just update it. And then finally, these two lines here are just some lines in the BrainRender scripts to just make some points that are sort of recognizable for plotting. So just include these in the function, and we've got an error here. This is saying that probably because we haven't got, it doesn't know what PD is, or so we haven't imported pandas. So that's just a case of just importing that at the top. So somewhere in here, you should just import that. So that's import. So before, what we were doing is we're saying, generate these random points. So now we can just get rid of that. And instead we can say, use our function. And actually, let's just get rid of this regions for now. And we can point to the file. So this is our cells file. So, grab this file and then run this function on it. And in here, just get rid of this regions as well. I'll show you this a little bit later, but right now we just want to process the file, this single file. And we can also add we can leave this brain region in. We don't need to have that MOS equals in front of it. We can just add this brain region to the scene. And, we can add some other ones. Like if we're interested in different brain region, you can add as many as you like here. So, I'm just going to add in another one. So as long as you know the acronym, you can just add in the brain region. You can add as many as you like. And then we're adding in the cells. So it's just reading them in, and then it's going to give them a color. So here you can choose the color as well. So sometimes it can be hard to know what color to use here. If you type in a color that doesn't exist, I think it actually prints out for you what color options there are. So we can just test that in a second. But this is basically all we need to do. And this might take a little bit longer now because there's actually a lot of cells that are in that file. And you can see it's not looking so good right now. We can definitely see the points. If you join for the ClearMap tutorial, then you'd recognize this block up here is kind of the artifact from the sort of glitches in the image, but this is the whole brain just here. But the orientation is not correct. And so to fix this, you can try and just think about what orientation might be wrong, or you can just try changing these. And in the case for this ClearMap, switching these axes should fix that problem. But if you're struggling with this after the tutorial, then just reach out and I'm happy to help you try and get this working. Okay, so now we have the cells plotting in the brain. Does everyone have that? Maybe just give me a thumbs up or just let me know in the chat before we move on. So a few things that I find silly mistakes that end up causing me some trouble when I'm doing this is just check your spelling. It's usually just one little typo that's causing a problem for you. So make sure that what you're calling this variable is exactly what you're calling it down here. Make sure you copied the path and have the double backslashes for everything. Another important thing with Python, spacing is really important. So if you just have a little bit of the wrong spacing like that, then this function won't run because the spacing's wrong. So just make sure that all your lines here are exactly, this is one tab in. So that's important. Yeah, great. Okay, so I think we're all up to this step. So we can plot a couple of different cells together or alternating. Just copy this line and paste it. And let's just call this cells file 2. So this brain that we're looking at right now, this is the saline brain. It's actually really hard to tell what's going on because there's so many points, but I'll show you how we can filter these in a second. With this line here, let's just change this to say HA. This will be the haloperidol treated brain. And all we have to change in our script now is this line down the bottom here. We can just say cells file 2. So we can close that and then just run the script again. It looks very similar, but there is actually quite a bit of difference between these two brains. But hopefully now you've got both of these data sets working. And now what we can start to do is drill down into, actually looking at individual brain regions. So, one of the things that most of you will want to do in terms of your presentations or just exploring the data yourself is to say, what's happening in the brain region that you care about the most. And so we need to filter this data somehow. And a way that we can do this is inside this function here. So just below where we have the filter for getting rid of the cells that are outside the brain, let's add a few extra lines. And I'll paste that in the chat for you guys. This is requiring another array called regions. And it's just, so we need to give that up just up here. So we can say here regions, and this is an array. So to make an array, we can use square brackets, and we can, for this brain, probably one of the more interesting areas to look at is the striatum. There should be a lot more activity there once the animal has been given haloperidol. So we can actually just get the brain ID for the Zuckerman is 672, and or you could actually use the acronym. I can show you how to use both of these. So we could do something similar with acronyms by saying CP. So now what this function is going to do is it's going to read in the cells, it'll get rid of the cells that are outside the brain, and then it's saying, okay, if this array called regions has got more than nothing in it, so there's something there, basically for the cells, we only want the cells that are in that region. So this is just going to filter the cells down to only those that are labeled with this ID number. And if we run this now, we're getting something that's a little bit easier to look at. So now we can see this is the haloperidol cells, and I can close this, and you can play with this yourself. Like just try plotting the other data set, and we can just change this down here. So you can see like there's a little bit of work in getting things going, but once you have this working, it becomes very fast to start looking at your data and generating screenshots and videos. And we're going to go through that in the next bit. And you can see here quite clearly now that we've filtered away all those surrounding cells that we can see a lot less cells in the striatum here. Okay, so we could also try and plot these together. We could say, so right now we're just saying put these coordinates in. We can just copy this line and say very simply like coordinates 2, and then we just give them the different file names. So that's going to be cell file 2. So I'll keep this consistent. Then we can give these, we can add them in and we can give them a different color. I need to say that this one should be coordinates 2. Okay. And so now we can see like the 2 different regions here. It can be a little bit hard to look at them like this. You can actually change the transparency of the cells as well. We can do that inside this function. Okay, so now you can see they're a little bit more transparent. Yeah, just before we go any further, I sort of jumped ahead a little bit before when I was showing you these settings. So there's actually a bunch of different settings in here that are quite useful. The background color, like, I mean, you can leave it as white. Actually, when you're doing the screenshots, the background's actually transparent. So it's quite nice for like making figures and things already, because this white area will actually be transparent. The default atlas, so this is using the Allen atlas, but of course you can use some other atlases that are available to look at the data. This camera view can be important. So by default, we're doing this sort of 3/4, but you can change this to top and sagittal and a few others. I think if you want to know what camera views are available, we can actually have a look. I'm pretty sure it's in cameras. So cameras actually has these, this is the names here. So sagittal, sagittal 2, frontal, top, and 3/4. So if you want to know what sort of options you have, like this is where you can look to type those in. So yeah, I think one thing that's helpful to change here, so quickly what we can do is just copy these. So anything that you're thinking of changing regularly, just put them in your script, and that way it's very easy to change them. So we can take this, and we can put this in our script. The root alpha, this is the transparency of the brain itself. So if you needed to just make the brain disappear, maybe you just want to show people the brain region, you don't want people to see the whole brain. So you can control that here. The other one that's useful, the shader style. So there's some different rendering styles. So cartoon is the one we're using right now, but the plastic one is actually pretty nice to use as well. So you can put that in here. I'm just going to change that now. And yeah, and show axes. So that, like, this is also good to get rid of. If you're just trying to make a nice clean movie, then maybe you don't want to show the axes. So we can get rid of those as well. So if I change this now to false, maybe I'll put this to a little bit lower. If I close this, so now you can see the brain is a little bit more faint, and we're sort of rendering the cells in here. And obviously, like, you can change these colors to be like colors of your choosing. And actually, I can just even get rid of these completely. Okay, so One other thing that we can do here that can be useful, because looking at the point clouds can be a little bit hard to interpret sometimes, we can actually, so BrainRender is really just about these simple visualizations, but you can do a little bit of work in terms of like plotting these densities or the density clouds, kind of like the heat map that you can generate in ClearMap and BrainJ. You don't have so much control over how transparent the plotting is, but I can show you how to do that. We just need to add a little bit at the bottom of the script here. There's another function called points density. In this case, we need to give it the coordinates. And this radius is how many points are within that radius. I think that's in microns. So just think about that in terms of, this is like a sphere with a 300 micron radius. And so that intensity will be based on how many cells fall within that sphere. And then we can give it a color and a transparency. You can see there's a warning here. This is because we haven't pulled in this points density. I think we just need to add this in. Yeah. And I'm just going to turn off these individual. Let's just get this basic thing working and we'll fix the colors. So this might take a little bit longer to render because it has to actually calculate these densities, but actually it's not too bad. So there's our, I guess that's our saline. Yeah, that's our saline. And if we add another, run this again, this will be our, okay, and you can see a little bit of a different density here. Actually, yeah, so a really important thing, like if you actually want to take screenshots of this data, then you just have to, it's actually very easy. When you're rendering it, so this is actually a nice way of getting consistent screenshots from, from the same angle. You can just type in the angle that you want to view the brain from, run the script, and once it's rendered, you can just press S, and S will take a screenshot and save it. This will save to wherever the active directory is. I think for me, that might be going to the desktop. If you're not, yeah, so there it is on the desktop here.
So,
If you,
sorry.
yeah.
So you can't save it any other way. There's no script to like, there's no line that you can write to save as
So,
image or movie.
yeah, so movie, yes, there's definitely a script for the screenshots. Like they sort of, you can control the resolution. I think it might even be a settings. Yeah, screenshot scale. So you can actually like maybe take a screenshot that's higher than the resolution of the screen. This way, if you need like a really high resolution image. And the other thing that like is useful if you're not sure where these files are going, and you need to save them in a specific location, in the scene, yeah, so just here where we set the scene title, we can also add another variable called, actually you can see it popping up now, screenshots folder. So you could actually type in screenshots folder and then specify like a directory that was on the computer that you wanted to save them to. Yeah, so that's how you can take the screenshots. And so you can see very quickly, like you could just change which brains or cells you're looking at and then just capture these, from different angles. Of course, if you're interested in just one hemisphere, like a lot of the ClearMap data is just the one hemisphere, we can slice, you can add a line in just down here. So this will slice and this will just slice, so we're getting a sagittal, so just one hemisphere. If we run this, then what we should get is just half of the brain. What I wanted to sort of take you through now is how to make movies using these scripts, because that's something that can be a little bit difficult to do just straight out of the box. What we can do maybe to start with is just try and open up the example script. So if you go to the examples folder, there will be a script for running video. So this video Python script here, this should be a short script that runs a couple of different movies and then saves them into a folder. And just try running that and see how you go. But most likely you'll have some errors. So it looks like it's working okay for me. Oh, okay, it's worked for me. But I don't know if it will work for you guys straight out. So just like, let me know how that goes for you and if you're seeing some errors, and I'll show you how to fix them. Okay, yeah, so it should close. Actually, maybe the best way is to have a look. These are it'll be saving to wherever your Active Directory is. So I think in my case, there should be a folder. I guess whatever this sort of folder is saying in your Spider application, this is likely where the files are going to be saving. So if you look in there, there should be a folder called examples. Have a look and see if you have these movie files. I know like an error that comes up a lot, at least when I've tried to do this, is that you need to have a program called ffmpeg. So if you can see, what I would do is look in this, you should have a view in the console here. If you have any errors, just let me know. If you're actually getting these videos, that's great, then we can move on. But like, definitely let me know if you're not getting the videos. Okay, yep. Yep, that's it. So, okay, cool. So yeah, this is kind of a pain, and like it can be, if you're not used to doing these things, could put you off using this tool, but it's actually pretty easy to fix. I can take you through the steps to do that. So if you close out of Spider, the first thing you might try and do is to do like a pip install this program. This is basically the program that can generate these movie files. So you can install this, and it's a very quick installation, but it still won't completely solve the problem. You need to actually download this application and install it, add it to the path. And so I can show you those steps now. So the website that you need to go to do this is the website we need to go to. So if just follow that link, and then depending, I mean, I think all of you are using PC, so we can just go to download here, and then the Windows exe files. This top option here, GYAN, like just download, click on this link, and then we want to download the full version of this ffmpeg. So if you download this, you may also need to download 7-zip. It's not always with Windows, so if you need to download that, that's just a free program, 7-zip, that unzips these files. So this is where you can download that. Yeah, so you can just download it here. And then once you've got 7-zip, this is the file just here. So you might, I don't know, like depends how your 7-zip is working on your computer, but if you're having some trouble unzipping it, just run 7-zip. And this folder inside the zip file, you can just extract this out, and we can rename this just a simple folder name. So we can just call it ffmpeg. And this folder, we can just copy to our program file. So we can just copy it in here. So I'm going to drag and drop this in here. So that's installed ffmpeg, but if we try and run the script to access it, it doesn't know where it is. And the way to solve this problem, this is basically adding a program to the path. And this just lets, like whenever you just type in ffmpeg, the computer will basically know that this program is in a particular folder. In our case, it should be in this folder just here. And the way to do this is you can just search in Windows. If you just start typing in system environment variables or system variables, you'll get this option in the control panel. And we want to change the environment variable. So if you click on environment variables, and just shout out if I'm going too fast here, but basically this is the path. So this is where we want to tell Windows that we have ffmpeg installed in a directory. So if we click on this path and then say edit, actually, this is why it ran for me before. I've already got it installed on this computer. But in your case, what you could do is just, I can delete this. Click new. And you could type in the directory here, or, using that trick I showed you before, just hold down Shift and copy as path. And then we can just paste in here the directory to the ffmpeg program. How's everyone doing? Yeah, just give me a thumbs up or an okay in the chat if we're all on the same page now. Okay, cool. All right, so let's move on. The next couple of things I want to show you is just how to make the videos, and then actually how to look at raw data and plot grid length. So we should be finished by 4. Okay, so that's all taken care of. And if we go back in here, we can just run our spider program again, and now we'll be able to run these animations and get it to work really well. And I think this is actually kind of where BrainRender starts to beat something like Imaris, because just even setting up the keyframes and doing things in a repeatable way with a lot of these different cell populations and brain regions can chew up so much time. And here you can just get a script working exactly as you like it for rendering the brain regions of your interest and your cells of interest in exactly the same way for different groups or different brains. And for us, all we have to do in here to get this rendering, we just need to add a couple of extra lines. So, okay, to render, there's just 2 lines that we need. So this time we're not going to use this scene content render. We're going to just use 2 lines. So the video maker is a function that creates the video. And actually, I'll put these in the chat as well. So the video maker creates this scene, and then we just need to tell it what to do. And so I've actually put in some notes here. These are there's 3 sort of variables, azimuth, elevation, and roll. And that's going to determine how the brain is moving. And it's going to move 1 degree per frame. So you're kind of setting it up here. So here, if I say 5, it's going to move 5 degrees per frame. And I'm doing 15 frames per second, and I'm doing 3 seconds. So it's basically going to do 45 frames, and it's going to rotate 5 degrees for each one of those frames. And it's going to save it into a directory called movies, and it's probably going to be in this directory here for me. I mean, I can just quickly change this to desktop. So if I run this now, it's probably going to give an error because it doesn't know about the video maker. So I just need to import that. So you would just need to add at the very top of the script, you need to also tell it, I mean, basically every time that you're using a particular part of BrainRender, just make sure that you have it imported. I'm just going to take. Yeah, so I guess I should have, movies. So just a tip, this is the movie I just created. I find that, if you're not using the full screen, they come out kind of looking squashed like this. So if you're trying to render them a little bit more rendering how you'd like them to look, just temporarily, put this back to true, and that will give you a much better result. I'm just going to run it again. Okay, and now I have my movie here. And obviously, if you're going to make this a little bit nicer, then I would recommend it's going to take too long for us, in this tutorial, but I would put this up to 30 frames per second, and I would put this down to 1, and then your duration will be a little bit longer. But that way you'll have a really nice looking movie that's nice and smooth. So that's how you can do a rotation. But if you want to do something a little bit fancier, like zooming in on a region or moving around, then you can do that as well. And that's actually done by adding in keyframes. And the way that you can do that, I can just copy these in here instead. Oops. And I'll share this in the chat. Now what we're doing is saying, instead of like doing just the rotation, I actually want to do some different views and different zooms. And so here we've just set some different views, and then we're saying how long the video should be. Actually, just going to change this. And if we run this now, okay, so again, we need to have the animation. I'm just going to go back up the top here and change this to animation. Yeah, and these are just quick like examples for the tutorial, but you could play around with this to get a different look to the data, and play around with these to get a really nice way of looking at the brain. And then once you've got that done, you don't have to change very much to create really nice renderings. Okay, the final thing that I wanted to show you is looking at raw data. So if you're using the BrainJ pipeline, and especially if you're trying to mark out locations of injection sites or grin lenses and things like that, then some really nice ways of doing that. So if you go into examples, you can see how to plot raw data. So I've got that under documents here, examples. So it'll be right down the bottom, volumetric data. And this actually lets you plot TIFF files that have come. This is mainly for the BrainJ pipeline where you've actually rendered projections in the Atlas space. But if you're working with a different pipeline that also transforms data into the Atlas space, then you can look at them inside BrainRender as well. And to do that, so if you just have a go just running this, maybe I've got the raw data only on this computer, but you can use this example raw data, which is a little bit faster to work with. This is just some low resolution data that's mapped in the hippocampus. If you're going to work with data from BrainJ, then it's actually important to install one more thing in the BrainRender environment, and that's called IMIO, which is an input-output library. So pip install. And what I'll also do is I'll share this, because I think the main things, especially if you some of the examples are quite good, but if you're working with the ClearMap and BrainJ data, then this is where you'll really hit a wall and like getting things to work, especially if you're new to using like things like Python and scripts. So I'll share these with working, like how to actually load in volumes and data so that you can get off the ground very quickly. So for us, now we've installed that, we can go back into Spider and we can just add a few extra lines to basically import the image data. And the example like I'll use, just because I don't want to take up too much more of your time, we'll just jump straight to the example using the grin lens, because I think that's a really good example of what's possible in BrainRender. So I have an example data set here using a grin lens. So if I look at this data set, I can show you quickly here. This has been registered in BrainJ, and you can see where the grin lens has gone into the brain. And we'd like to be able to sort of look at that and also be able to place a marker to show where that is, and even measure the distance of where that lens is. And so to do that, we need to import actually we already have it here. So we've got the BrainRender actors volume, and we just need to tell it where our data set is. So to do this, and we also need one more line up the top here. We need to tell it to use that IMIO. This will let us load in the TIFF file. So we're basically just saying the volume is this file, and we're using the load function. And this directory will be the directory that we have that image in. So I can just copy that using Shift and right click, copy as path, and just replace this. Just very quickly update this. And because we have this issue with the orientations between the way BrainJ works and BrainRender works, we just need to make sure that we swap the axes. So this is just making sure it will render exactly as it should inside the annotated brain. And then we need to set a couple of things. So we need to control a little bit about how this looks. So this, we can basically create an actor for this volume. And I can put this in the chat for you as well. So basically we're importing the file, we're rotating it, and then we're creating an actor out of it. And so we're basically saying, take that volume, make sure that the voxel size is 25 because we're working in microns. We're not going to create a surface over it. We're just going to plot the raw intensity, and we're using a green color map. And then finally, we can add this to the scene. Okay, so this is now that raw data. We don't really have much of a look at it in terms of transparency, but we can at least see that DAPI data, and we can see kind of where this grin lens is. And what, maybe you actually want to plot this in a better way. And so what you can do, if you want to plot something, they give an example in here about plotting a cylinder. So if I just open this and show you very quickly in the examples, there should be a cylinder. So, in here, they're rendering the thalamus and they're putting in a cylinder there. And if I just run this, you can see how this works. So this sort of cylinder goes right dead in the middle of this region. And probably for many of you, you're actually targeting a specific subregion of the brain, and you want to show people like exactly the location that you're targeting. And the way to do that is the way you can do this, you can look, so if I open up that data set from BrainJ, because this is in the Common Coordinate Framework, if I hover the cursor around where the lens is, if you pay attention to the status bar in Fiji, you'll actually see the coordinates. So the X, Y, and Z coordinates there, that's the location of the cursor. And we can actually use those inside the script. So in here, if we wanted to add a cylinder, and we can tell it those exact coordinates. Now, remember that the coordinates are swapped, and in the case of BrainJ, the X and Z axes are swapped. So instead of saying like 337, 144, 173, you would write that the other way around. And because these are voxels, not microns, we need to multiply them by 25. So we just say multiply these positions by 25. And then we can just say to add the cylinder at that exact position, and then try and see what that looks like. And so now we can render the raw data and actually look at it with the cylinder. And at this stage, I just need to tell it to put that in. So with any of these, once you create them, you need to actually add them in as well. So I'm just going to add in, this is our actor 2. So hopefully now when I run this, we'll be able to see both the data and the cylinder. So if we look at this now, we can actually see that this is actually nicely going right down inside where the grin lens was positioned. And what we can do to look at this a little bit more clearly, I've annotated this data a little bit, and in this one, I've kind of just filled in the area where we know the imaging plane was. That's in C4. And what I'm going to do is actually say true here to turn it into a surface. So it's actually going to be just filtering out a lot of the intensity from all the DAPI. It won't be perfectly clean, but it's going to be pretty clean once I put the threshold up pretty high here. And now if we render these together, we'll be able to see the cylinder, but we should also be able to see roughly where the imaging plane was together in the same brain. This will take a few seconds longer to render because we're now processing raw data. But hopefully you can see now, like, this is how good we can get it by measuring that location in the BrainJ dataset. This is our kind of theoretical window that we're seeing with the grin lens. And this is our grin lens going into the brain. And one final thing that we could add to this, so they could use this again with all the animation and orientation views to get some nice screenshots of this. One final thing that we could do is also measure that distance from the brain surface. So to do that, we can just add in, instead of adding in a cylinder, we can add in a ruler. And this is just 2 lines of code. And so what we're saying is just create a ruler, and there's a tool called ruler from surface. From the position to the surface of the brain, this is the root is kind of like just the whole brain, and give a scaling in millimeters, and then add that ruler to the image. And I'm just going to turn off the cylinder so we can see that clearly. And then that's kind of the last kind of example for us. Yeah, and this is really the last thing that I wanted to show you guys in the brain render. So you can see now we have this nice like measurement showing the depth of the grin lens. And you can use it, we could render the, stratum in here, and we could render and measure like distances to other brain regions if we were interested in that. So that kind of concludes like the different examples. We're almost about to hit 4 o'clock. Does anyone have any specific questions, or is there anything that wasn't so clear? I know some of this stuff was a little bit difficult to do over Zoom, but hopefully it was helpful for you guys.
I have a question. I mean, this was very helpful. So I know you used the example of the ClearMap for this, but is this generalizable to BrainJ data?
Oh yeah, absolutely. So this data that we're looking at right now is from BrainJ,
Right.
and the cell import for BrainJ, I have that working as well. So I'll share like scripts for the cell import for BrainJ with the filtering for the different brain regions.
Okay.
And
so
I'll share
what? Oh, sorry.
Yeah, no, you go.
I was gonna ask. So what's the benefit of using the BrainRender versus just using like what BrainJ spits out, or I guess what's the differences between the two?
Oh, sure. So I mean, the big difference is like the data that we generate from BrainJ, there are all these sort of TIFF images. And you can make these in 3D. Like I think when, in the pipeline, I generate a whole lot of little 3D TIFFs that are kind of useful for, just getting an idea of what's happening. But if it comes to like, making a figure for a paper or a presentation where you're trying to show a grin lens or something like that, then, the best you could do with BrainJ is probably, do something like, I can very quickly show you. This is where I annotated the grin lens. So I've made like a really bright region here. And if I look at that in 3D, it's going to be a little bit ugly. Like that's kind of voxelated and sort of blocky. This way you'll have like a nice smooth rendering of the lens, and you have much nicer renderings of the annotations. And one thing that's really difficult to do quickly in something like Imaris is creating all the surfaces for all these brain regions and then adding in the cells. You can end up spending hours on there. So the reason I wanted to show BrainRender as kind of a sort of final sort of workshop in this sort of 3-part series is this is just a massive time saver for making really good renderings of like complex data sets in like literally like once you have this script done, like you can render cells in a region within like 5 minutes rather than like 2 hours at Imaris and maybe a lot of, painful back and forth to get everything working nicely. So that's kind of, this doesn't, BrainRender itself doesn't do any of the mapping and analysis. It really just plots the data. Although the Sainsbury Wellcome Trust, people who developed this also have some nice tools for doing analysis too. But this is really just for rendering, if that
Okay.
makes sense.
Yeah, totally makes sense. Thank you.
Okay, is there any other questions? Okay, yeah, we'll wrap it up. And, I'll share by email these scripts, like probably in a couple of days, and the video, just reach out and I can share it with you privately, and we'll probably edit it and share it more broadly later. Yeah, and then if you have any questions about this stuff, just don't hesitate to reach out and I'll help you if I can. Okay, yeah, thank you for your time.